Welcome to this last session where we deal with all the various terms and notations which you have learned in properties of trees. A connected graph which has no cycles is called a tree. A forest consists of a set of disconnected trees. In a tree there is one and only one path between every pair of vertices. A tree with n vertices has n-1 edges. A connected graph with n vertices and n-1 edges is a tree. If F is a forest with k trees, n vertices and m edges, then n is m plus k. A pendant vertex or a leaf is a vertex of degree 1. A tree with two or more vertices contains at least two pendant vertices. If a tree has exactly two pendant vertices, then degree of every non-pendant vertex is 2. A directed tree is called a rooted tree if T contains a unique vertex called the root R whose in degree is 0 and in degree of all other vertices is 1. So what is a property of a rooted tree? You have one vertex called the root having in degree 0 and in degree of all other vertices is 1. A vertex V of a rooted tree is said to be at the kth level if the path from the root R to V is of length k. If V1 and V2 are such that V1 is at a lower level number than V2 and there is an edge between V1 and V2, then V1 is called a parent of V2 or V2 is called a child of V1. A vertex which is not a pendant vertex is called an internal vertex. A rooted tree is called an M-array tree if every internal vertex of T has at most M children. And a rooted tree is called a complete M-array tree if every internal vertex of T has exactly M children. A rooted tree which is a two-array tree is called a binary tree if every internal vertex of T has at most 2 children. Let T be a complete M-array tree with P leaves and Q internal vertices, then n equal to MP minus 1 by M minus 1. Q is P minus 1 by M minus 1. These are important results to remember with lot of practical applications. P equal to Q into M minus 1 plus 1, N equal to QM plus 1. All these are derived by simplifying the first formula. In the merge sort method, we split the numbers into half or as close to half as possible. Divide the unsorted list into sublists, each containing one element. Take adjacent pairs and merge them together. Repeat the process until a single sorted list is obtained. Thank you, and do let me know your feedback.